Okay, so we are talking about sets. We already defined the set and we have discussed the we have talked about the subset now today we will discuss the now we will define state operations. Before that we already defined the subsets. Subset we have defined in the last class. So, that means A is a subset of B if and only if element x belongs to A imply x belongs to B. Okay. So, now we define when we say two sets are equal, A equal to B, this is the equality. When we say two sets are equal. So, we say two sets are equal if and only if A is a subset of B and both the condition and B is a subset of A. If both satisfy, then only we say A is equal to B. Okay, this is the definition of equality of two sets. So, what is the meaning of this? Meaning of this is, so for all x belongs to A, we have to show x belongs to B, and for all y belongs to B, we have to show that y belongs to A. If this is satisfied, then we say these two sets are equal, A equal to B. Okay. So, now we define some operation on the sets, basically we define union and intersection. So, these are called set operations. So, first one is say union operations. So, we have two sets A B. So, what do you mean by A union B? Okay, so, that we define. So, let A and B be two non-empty set then we define A union B is basically this is again a set. So, when we are operating union on two set, this will give us another set. And what is the properties of this set? Properties of this set is the element in this new set will be either from A or from B. So, it is basically this is the x such that x is from A or x is from B. So, this is the OR of OR. So, that means this new set consists of all the elements, that elements coming from either from A or from B. Okay. So, like if we have for example, this is the definition, this is the definition of the union. Now, if for example, if you have two set A is say 1, 2, 3, 4 and if we have another set say 2, 4, 5, 6, another set B. Okay. Now, how we define union? Union is basically another set C which is denoted by this symbol. So, then A union B is basically, so 1, 2, 2 is in the both place, but we cannot write 2 twice because set is a distinct collection of object. So, 1, 2, 3 again 4 will become ones. So, this will be distinct collection. So, this is the union. So, union set is basically this is. So, the either A is belongs to x is belongs to A or x is belongs to B. So, this is called union operations. Okay. So, now we define the intersection operation. So, intersection which is denoting by this symbol. So, we have two, again we have two non-empty set A B. So, A intersection B is another set which is having properties that these elements must be in both the set. So, this consists of the common element and. So, these elements has to be present in both the set, then those collection of those elements is basically the intersection of this. Now, for example, this is the definition. Now, example is this is the definition. Now, the example is, now if we have this set say 1, 2, 3, 4, and if we have this set say 2, 3, 5, 6, 2, 4, 5, 6, then what is the intersection? Is this 3 belongs to this intersection? Intersection is again another set, but that set having the property that element of this set must be an element of both the set. Now, is 3 belongs to this intersection? No, because 3 belongs to A, but 3 does not belongs to B. So, this 3 is not having this property, both it must belongs to both A and B, but 2 has this property, 2 belongs to A and 2 belongs to B. So, 2 has this property and 4 has this property. So, this is the intersection set, okay. A intersection B. So, now we have, if we have say B is say like this. So, if A is this, then say if we have B is say 5, 6, 7, 8. Now, what is the intersection of this? Is there any element which is common in both? No. So, intersection is the null set. So, A intersection B is null over here if they are having no common element in that set. Okay. So, now we will discuss some properties of this union and intersection. Okay. So, what are the properties? Say like first property is, these are the properties of the set operations. Basically, we have learned two operations, union and intersection. So, we will define some of the, we will discuss some of the properties based on that. Okay, the first property we discuss is, suppose B is a subset of A. Okay. Then what is the union? Then A union B is basically, B is a subset of A. So, A union B is basically A and A intersection B is basically B. Okay. So, how to prove this? So, to prove this, so let us try to prove this one first. So, A union B is basically, so these two are equal. Equal means this is x, this is x. So, what we have to show? We have to show x equal to a set x equal to another set A. So, to show this, what we need to show? We need to show the x is a subset of A and A is a subset of x. Now, this part is obvious because this x is nothing but A union B. So, every A is a subset of A union B, because union means basically the elements of A along with the other elements of B which are not common in A. So, this collection consists of A union B. So, this part is obvious. Now, we have to prove this part, that X is a subset of this. So, to prove this part, what we need to show? We need to take an element X from X, and then we have to finally show that X belongs to A. So, now what is X? X is A union. So, let us take small a. Okay. Now, this is means A belongs to A or A belongs to B. Now, suppose A belongs to A, there are two cases, either A belongs to A or A belongs to B. Now, if A belongs to A, then A belongs to A, that is done. Now, otherwise if A belongs to B, now B is a subset of A. So, that gives us this implies A belongs to A, because B is a subset of A. So, in any case A belongs to A. So, A belongs to X means A belongs to A. So, that means X is a subset of A, because this is an arbitrary element. This is for all A belongs to X. We take an arbitrary element from X, and then we have proved that A belongs to A. So, X is a subset of A. So, that means, and we have already A is a subset of X. So, that is when this is true. So, similarly, this also we can show. Okay. So, this is one property. Now, another property is with the null set, A union of null set equal to A, because null sets consist of no elements. So, if you take the union with any other set including null set, then it will be that set, and A intersection null set is empty, because there is no common element, because null sets consist of no element. It is just a symbol, it is a convention to have such a set, because when we have two set which having no common element, then their intersection is containing no elements. How to represent that? To represent that, we have to bring the notion of the null set. So, null set is the set with no element. Okay. So, the next property is with the universal set, A union universal set is basically universal set, A intersection universal set is A, because every set is a subset of the universal set. So, it is coming from there. Okay, the next property is A union A is A. It is very easy to convince. A intersection A is A. Quite obvious, because just we are taking this. Okay. So, now the next property is the commutative property, like A union B is same as B union A. This is called commutative property. Commutative. It does not matter which, we take A first or B first. It only matters is the elements of that set. So, A union B is same as B union A. Similarly, A intersection B is same as B intersection A. So, the ordering really, ordering is not so important. So, this is a commutative sense, and we have another property which is the associativity property. This property is called associativity. So, if we take three sets A, B, C, 3 non-empty set, even this is true for empty set also. If you take 3 arbitrary set A, B, C, so then A union B union C is basically A union B union C, and this is true for intersection also. A intersection B intersection C. Okay. So, this is the associativity property. Now, we have, if we want to combine this union and intersection, then we have another property which will prove that. So, the combination. So, suppose we have A union B intersection C. So, this is basically A union B, then intersection A union C. This is a property. So, now how to prove this property? We are going to prove this property. Yeah. So, A union B intersection C, here we have union, here we have intersection, then it will be A union B intersection A union C. Now we have two sets to prove equal. So, this is a x set, this is y set. We have to prove x equal to y. So, how to prove that? We know when the two sets are equal, if x is a subset of y, first of all we have to see x is a subset of y or not, and if it is done, then we have to check y is a subset of x or not. So, let us try the first one. We are going to see whether x is a subset of y or not. So, for that what we need to take? We need to take an element of x, arbitrary element, and we have to show that that element belongs to y. Okay. So, if this is true for all element, then we get through. So, let us try that. So, this is our x, this is our y, this whole set. Okay. So, let us take an element from x. So, A belongs to x. So, this whole set is y, not only this. Okay. So, A belongs to x means x is nothing but A union B intersection C. So, that means A belongs to A or A belongs to B intersection C. Now, this means what? This means A belongs to A, or so A belongs to B intersection C means A has to belongs to B and A belongs to C. Okay. Now, if so, this is basically A belongs to this or this. So, suppose A belongs to, there are two cases now. If A belongs to A, first case, if A belongs to A, then A must belongs to both of this. A must belongs to A union B and A union C. So, A must belongs to this both intersection. Second case, suppose A belongs to these two. Suppose this is not happening, this two is happening. A belongs to B, and if A belongs to B, then A has to belongs to C. In that case, A belongs to this one and A belongs to this one. So, in the both the cases, A belongs to intersection of these two. So, this implies A belongs to Y. So, this implies x is a subset of y. Okay. Now, the other way around, we have to prove y is a subset of x. So, we take an element from y. So, this type of argument you have to do when we try to prove this type of property. So, we have to show now y is a subset of x. So, for that we need to take an element say B. B from Y. So, Y is basically A intersection A union B intersection A union C. So, this implies so Y belongs to A has to belongs to both of these A intersection B and B belongs to A intersection C. Now, this implies first one implies B belongs to either A or B belongs to capital B, and this is together, and B belongs to A or B belongs to C. Okay. So, now there are few cases like if B belongs to A, and here so there are 4 options: B belongs to A and B belongs to C there. So, if B belongs to A, then B belongs to this union. Otherwise, if B does not belongs to A, so then B must belongs to capital B, and if B does not belongs to A, then B must belongs to capital C. So, in the both the cases, so this B belongs to X. So, that means this implies Y is a subset of X. Okay. So, this implies Y is a subset of X. So, hence we prove these two sets are equal. So, this is one of the properties. So, we prove this type of properties by using this argument. Okay. So, another properties is based on the complement. So, we first define the complement of a set, complement operation, complementation. So, we define this is the definition. So, let A is a subset, then what do we mean by complement of A? We denote complement of A by this, or sometimes it is denoted by this symbol. So, this is basically set of all element from the universe where X does not belongs to A. So, this is basically the element which is not belongs to A, which are coming from the universe. Now, for example, suppose our A is say 1, 2, 3, 4 and our universe is say 1, 2, 3, 4, 5, 6. Suppose this is our universe, then what is A complement? A complement is nothing but set of all elements coming from the universe which are not in A. So, that means 5 and 6. Okay. So, these are the element not in A. So, now we will have some, this is the definition of the complement. Now, we will have some properties of this complement. So, first property is A complement complement, it is basically A. This is quite easy to convince or easy to prove. Now, second property is A complement, if we take the universe A with the A complement, this is the universe, and this is quite obvious property, because complement consists of the element which are not in A. So, their intersection must not have, they have no common element. So, the intersection will be null. Now, another property which is called De Morgan's law, which is basically De Morgan's law, which is basically A intersection B complement is equal to A complement. This is union and this is intersection. A complement and B complement. This is first De Morgan law, and second one is with the intersection. This is intersection, so it will be union over here. So, A intersection B complement will be is equal to A complement union of B complement. So, this is the these two laws are called De Morgan's law. We will prove these two properties in the next class. So, before and also we will define the what is called Venn diagram method. So, we can represent the graph in a pictorial way, in a diagram way, and then we will then it will help us to prove all this property very easily. So, we will discuss those in the next class. Thank you.